is Murthy, as assistant professor in the Department of Mathematics, SR University, Warangal, India. So today I am going to teach you about the multilinear regression. Let's start the lecture with the multilinear regression. So this is the definition of the multilinear regression. So here you can see the multilinear regression is a statistical technique that models the relationship of the dependent variable and independent, very important, one dependent variable and two or more independent variables. Two or more independent variables. So here the general equation of the multilinear regression is this: y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus up to beta k plus epsilon. So why multilinear regression is useful? Because to predict the factors such as size, location score, and number of bedrooms. So for that purpose, we'll use the multilinear regression. Next, coming to that, why it is useful. That is very important. So why it is useful? Just tell me why multilinear regression is useful. Yes. Because multilinear regression having the linear relationship between the dependent variable and independent variable, it is linear relationship. Linear relationship between means when y value increases, then simultaneously x1, x2, x3 up to xk value also. That is a linear relation. Okay, and here the mean equals to 0 and variance equals to sigma. Okay, students. So next, coming to the important factor, that is the interpreting coefficients. So here beta z, that is the expected change in y, and beta naught, beta 1, those are the regression coefficients. Regression coefficients. That is beta naught, beta 1, beta 2 up to beta 3. So this is very important problem formula to solve the problem using the multilinear regression. And the equation basically y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon for two independent variables. Generally, problems comes based on two independent variables. Okay, students. So here, two independent variables, we need to use that formula. And after interpreting this formula, we need to see where we can calculate the beta naught, where we can calculate the beta 1 and beta 2. Now tell me, if y equals to beta naught plus beta 1 x1 plus beta 2 x2 up to plus epsilon, then beta naught we can calculate, that is y bar minus beta 1 x1 bar beta 2 x2 bar. And beta 1, this is very important. This formula we need to apply. That is equals to sum of x2 square into sum of x1 into y minus sum of x1 x2 into sum of x2 into y divided by sum of x1 square into sum of x2 square minus sum of x1 x2 square. So students, here This is very important. Beta 1, beta 2, these values, beta 1, beta 2, these values we need to implement to find the value of beta 1 and beta 2. And after calculating beta 1 and beta 2, to see how we to calculate the sum of xi square. Means suppose sum of x1 square, we need to calculate. So how to calculate that? We need to check. Yes, now tell me sum of xi square, that is equals to sum of small xi square minus sum of xi square whole square divided by this formula. Similar way, sum of xi into y, similarly summation of small xi into y minus summation of xi, summation of y divided by that formula. Similarly, summation of x1 and x2 is equals to summation of small x1 and x2 minus summation of x1 into summation of x2 divided by. So these are the ways where we can calculate, where you can predict the value of beta naught, beta 1 and beta 2, and simultaneously also the value of xi square and x1 xi into y square, xi into y, and simultaneously x1 into x2. Okay. Next, we will go to the problem after this formula. This is the coefficient of the determination. The coefficient of the determination, that is the statistical metric. Here you see that the statistical metric is to measure how much variation are there in the independent variables. That is R square. It can be R square between 0 to 1. That means outcome cannot predict it. Outcome cannot. And if that R square equals to 1, that means we can predict the outcome. Can predict the outcome without errors, without any error. Okay, students. So this is all about the coefficient of determination. Next, coming to the problem. One problem is that try to understand this question next. So the question, the value of x1, x2, and y means independent variable and dependent variable will be given itself in the question. Just we need to apply that formula of multilinear regression to find the value. So here x1 value is already given. So that is for 1200 is x2 is algorithm is 2, and x1 is 1500 x2 value is 3 and y value is 65. 1500 x2 value is 3, y value is 80. 3000 x2 value is 4, y value is 90. 2200 x2 value is 4, y value is 9. So we need to fit here, we need to fit a multiple linear regression. Just we need to fit here a multiple linear regression. Yes, students. So and predict the output for 58 machines and 7 workers. So to predict that, what we need to do, students? So let's come to the solution part. So here y value is given. Y value is given. Y equals, here you see y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus xn. And in the first question, see the x1 value, that is the size 1200, 1500, 1800, 2000, 2000. Similarly, x2, 2, 3, 3, 4, 4. Similarly, y value 50, 65, 80, 92, and 100. So after this three value, what we need to do? Now we need to calculate the x1 square. And here we need to find the sum of x1 square. Similarly, here we need to calculate x2 square. And we have to find a sum of x2 square. Similarly, here we need to calculate x1 into y. And similarly, we need to find the sum of x1 into y. Similarly, here we need to calculate x2y. And here we have to find the sum of x2. At last, we have to calculate x1 into x2, and here we have to calculate the sum of x1 and x2. By that way, we need to find 7 columns. 7 columns. We need to construct. So next, after finding these values, we need to calculate the sum of x1 square. That is sum of small x1 square minus sum of small x1 square divided by 5 is 632 equal to this value. Similarly, sum of x2 square also we need to find, that is 2.8, right? Next, after finding this, we need to compute the sum of x2 into y. Sorry, sum of x1 into y. To compute. Because after computing all these values, we can apply these values to find a solution, right? So here, sum of x1 into y, that is equal to sum of x1 y minus sum of x1 into sum of y divided by n. N means n value is 5 here. So we will get 32,100. After that, similarly, sum of x2 into y equals to sum of x2y minus sum of x2 into y divided by 5. Because n value is 5, so that is 64.6. Similarly, sum of x1 into x2, that value is equal to sum of small x1 x2 minus sum of x1 sum of x2 divided by 5. That is 1260. After computing all these values, we need to find the value of beta 1 and beta 2. Right. So directly we can apply the formula. Here we see that beta 1 equals to, what is the formula for finding beta 1? That is sum of, see this formula. This formula is very important. So sum of x2 square into sum of x1 y minus sum of x1 x2 into sum of x2 y divided by sum x1 square x2 square minus x1 and x2 square. So after finding this value is 0.04622308. This value we need to, this is the value of the beta 1. After finding beta 1, we need to find the beta 2. So beta 2 similarly also same formula will apply for beta 2. And we'll find this value 1.5604316. After finding beta 1 and beta 2, y value equals to beta naught equals to y minus beta 1 x1 bar minus beta 2 x2 y. That is equals to here summation y divided by 5 minus beta 1 into summation x1 divided by n minus beta 2 into summation x1 divided by. So this value will get this minus 10.505494 and 51. So after computing all these values, we need to construct the equation. That is very important. So here that y value equals to, what is the formula? Beta naught plus beta 1 x1 plus beta 2 x2. So here that y equals to beta naught is minus 10.50549451 plus 0.04692308 into x1 plus 1.95604396. Everybody understood this? So this is the way by this we can calculate the y. So this is the multilinear regression model. After finding this, let us concentrate on the x1 and x2 part. So here x1 is given 1600 and x2 is given 2. So as x1 is 1600 and x2 is 3, in this x1 and x2, we need to apply these values. So what we'll get? Here we'll get this value is minus 10.5494 into here 1600 here we apply, and here the x2 value is 3 will apply. So around 70.4396 lakhs is the answer. Okay, students. So this way we can model the multilinear regression and we can find the value of y. Next, coming to the second question. A factory manager analyze the daily output based on the x1 value is here. Here you see x1 is machine hour, machine hours used. X2 is number of workers. So x1, x2 value is given. X1 is 40, x2 is 5, and y value is 180. X1 is 50, x2 is 6, then y value is 210. X1 is 55, x2 is 7, then y value is 230. X1 is 60, x2 is 7, then y value is 245. X1 65, x2 value is 8, then y value is 27. Now, based on this input, we need to calculate, we need to build the multilinear regression model, and we need to predict the 58 machine hour and 7 workers. Second question, 58, this 58 is the x1 value, and 7 workers means x2 value is 7, is given in the question. Okay, students, next let's come to the solution part. So, as we solve the problem 2, means second problem, and the second problem, same formula we need to apply here. I'll show you the formula. This formula, beta 1 and beta 2. So the same formula here we need to apply and to find the beta naught, beta 1 and beta 2. Okay. So here the same formula, that sum of x2 square into sum of x and y. So here in the second problem also same formula we need to apply. And here we apply the same formula. So directly it is written there. So beta naught will get the beta naught value equal to 33, beta 1 value equal to 2.53, beta 2 value equal to 8.66. So these values will get after we incorporate this formula, multilinear regression, beta naught, beta 1 and beta 2. After all these things, after finding the beta 1, beta 2, beta naught, beta 1 and beta 2, we need to construct the multilinear regression model. So to construct the multilinear regression model, we need to find the y value, that is beta naught plus beta 1 x1 plus beta 2. So beta naught is 33 plus beta 1 x1. Beta 1 x1 is 2.5 double 3 into x1 plus 8.66 into x2. After these values, here x1 is given 58, x2 is given 7. So we'll apply the same formula to find x1 is 58 and x2 here to find x2 value is 7. So here the y value equals to, here you can see the y value equals to beta naught, that is 33 plus beta 1 into x1. Beta 1 is 2.53 into x1 is 58 plus beta 2 x2. Beta 2 is 8.66 into 7. So that is approximately 240.6. Okay, so anyone having any doubt? So by this way we can compute the value of y. Here we can, this way we can compute the value of y. Okay, so y is approximately 240.6, right? Next, coming to the another problem. So here the problem is explaining that, try to understand this question. A manufacturing company wants to study how machine operates, hour and number of workers, right? To influence its daily production output. The production manager collects the data for 5 different days and recording the total machine hours used, the number of workers employed, the resulting output. Here the output is given. The machine hours is given for 35. Number of workers is 4. The value of it is 160. That means this is the value of x2, this is the value of x1, and this is the value of y. Right? So we need to fit a multilinear regression model. Only we need to calculate using the same value, sum of x1 we need to compute. That is sum of small x1 minus x1 square minus sum of x1 whole square divided by 1. So similar formula we need to apply here. We need to calculate the beta 1 and we need to calculate the beta naught, that is y minus beta 1 x1 minus beta 2 x2. Similar formula we need to apply here. So after applying the similar formula, means for beta naught, beta 1 and beta 2, then we need to apply and find the multilinear regression model. So multilinear regression model we can use here and we can find this value y equals to similar beta naught plus beta 1 x1 plus beta 2 x2. Okay. So these values we can able to find here, and here the beta naught equals to 33 after using this formula. Beta 1 equal to 3.53, beta 2 equals to 3.66. Okay, students. So after getting these values, we need to apply this formula. Beta 1 not equal to 33 plus 3.53, 3.53 x1, that is beta 1 value, 3.5, in beta 2 is 3.66 into x2. So this way we can calculate the y value. Okay. Coming to the next practice problem. The problem, a manufacturing company wants to examine how machine operating hours and a number of workers affect its daily production output. The production manager records the following data over 5 different days. Over 5 different days. Here the machine hours is given for 30 it is 4, for 40 it is 5, for 48 it is 5, for 52 it is 6, for 53 it is 7. Means x1 and x2 value. Here the y value is given 145, 175, 200, 220, and 200. So we need to fit a multilinear regression model. How to fit that? Y equals to, what is the formula? Beta naught plus beta 1 x1 plus beta 2 x2. And beta naught we will calculate using the formula y minus beta 1 x1 minus beta 2 x2. That beta naught value equals to 27.48. Here you can see this beta naught value is 27. This is the value of the beta naught. And this is the 2.69. This is the value of the beta 1. That means beta 1 x1 plus 8.72. That is beta 2 into h2. So this is the y value. Here we can find this. And the answer is 27.48 plus 2.69 into x1 plus 8.72 into. So students, that is the way to calculate the multilinear regression. And here you can see that these values, that's y values, that is very important here. So, and while calculating the beta 1 and beta 2, I'll show you again how to calculate the beta 1 and beta 2. This, after calculating this, we'll apply this formula beta naught plus beta 1 plus beta 2. So here is one slide that is very important. This slide. So, and so I'll write the formula again because Yeah, in exam you need to remember this formula. Otherwise, it's difficult to calculate. So here, just see. First of all, we need to calculate the beta naught. That is equals to y bar minus beta 1 into x1 bar minus beta 2 into h2 bar. And that is summation y bar is summation y divided by n minus beta 1 summation x1 divided by n minus beta 2 summation x2 divided by n. By this way, we can calculate the beta naught value. Right? After calculating the beta naught value, we need to calculate the beta 1 value. Right? So here, the beta 1 that is equals to summation of x2 square, capital H, into summation of x1 into y minus summation of x1 into x2 into summation of x2 into y divided by summation of x1 square summation of h2 square minus summation of x1 into h2 whole square. So students, this is the formula actually to find the beta 1. So in all these problems, these and these problems, the beta 1 is 2.33, this one 2.533, this value of beta 1 calculated by using the formula. So this formula you need to remember because we can apply this formula to the beta 1. And after finding beta 1, we need to calculate the beta 2 value. So how to calculate the beta 2 value? Must go to the beta 2 formula. Here we will see that this beta 2 equals to summation of x1 square into summation of x2 into y minus summation of x1 into x2 summation of x1 into y divided by summation x1 square summation x2 square minus summation of x1 into x2 whole square. Listen students, here what is the difference? You can those two, that means here directly you can find the beta 1 and beta 2 using this formula. All things are same. Only here, what is the difference here? Here, the summation x2 square is in beta 1, rest things are all are same. This is x1 into y, rest all things are same. But here, it is about x1 square, summation x1 square, and summation of x2 into y, and all rest things are same. Okay, as the previous. So, that is very simple to remember the formula. So you can apply this formula and directly you can solve this question using this formula. And directly you can find this beta naught and beta 2 value, which is very helpful to find the beta 1 and beta 2 value. And we can substitute in the equation to find the value. Right? So here you see in the practice problem it has given this. So same formula for beta naught, beta 1 and beta 2, and we can find this value. Because by applying this formula only, beta naught we found that is 27.48. Beta, sorry, this is beta naught value. This is beta 1 value, that is 2.69. And beta 2 value, that is 5.7. Okay, so here directly you can write this. This is the normal equation for two independent variables given beta naught plus beta 1 x1 plus beta 2 x2. Right, so that is equal to 27.48 plus 2.69 into x1 plus 8.72 into x2. Now, easily you can write this formula and you can find out the solution. Okay, students. So thank you for listening this multilinear regression. This is very helpful to find here the application is there. I have already explained the application where it is most applicable. So basically, it is applicable to find the size, location, and score. Means suppose we are going to start one room. So what is the size? What is the how many number of bedrooms are there? So that regression coefficient will be you to find. That is that's why it is multilinear. Means one dependent variable y and with respect to two or more independent variable, that is x1, x2, and scale. Basically, the problem based on two independent variables. So only y is equal to beta naught plus beta 1 x1 plus beta 2 x2. Okay, students. So this is all about the multilinear regression. Okay, thank you for listening. So any further queries we will discuss in the next program, in the next class. Okay, thank you for listening this lecture. Thank you.